So now let's look at the higher level protocols such as FTP, Telnet, DNS, and we'll find that these build on the basic infrastructure of Ethernet, IP, TCP, UDP. Okay, so this was our layered model that we looked at before. We had our data link at layer 2, that was Ethernet, then IP at layer 3, network layer, TCP is layer 4, and then our application layer protocols sit on top of this protocol stack and really use TCP and IP to be able to get the data delivered and then to be able to segment it up and then for it to be rebuilt again. So have a look at some basic protocols at these higher level layers, such as HTTP, FTP, Telnet, SNMTP. As we remember, the ports that we use, so the server uses a well-known port in which we connect to. So if we want to connect to FTP, the server normally listens on port 21, and then we can connect to that. The ports can be movable, but these are the standard ones that are used. Telnet we'll see a bit later on in one of the modules, and SSH are for remote access. SMTP is for sending email. DNS we'll see, and we'll see that DNS uses UDP typically and not TCP. Then we see some other protocols here, and port 80 is an important one, and that's used with HTTP or for web browser access. Okay, so if we recap, basically we create our own client TCP port and we connect to a destination port, and the address and the port on the other side binds the whole connection. So we're going to have a look at some application layer protocols, and the first one we're going to have a look at is HTTP. So HTTP normally uses TCP and IP to be able to transmit the data. And basically it's a very simple protocol. Basically it is called stateless. And it's stateless because really it doesn't remember anything about the connection. And we have a very simple request and reply. So in terms of the request, we have 4 main options for that: get, head, post and put. The get is used to get a URL or a web page from the server. Head will just display the header information of the request, and post is used to post an entity to the website, and put allows us to put the entity inside an existing resource. Many web services on the internet actually use get, post and put, but the main one we'll look at is get, and get is the one that allows the browser to be able to get a web page from a server. Along with sending the get, we also have a whole lot of options, and these options define the types of formats that we might want to accept. Also we ask, has the content changed since a certain time? We might give our host name, our browser name, whether we want to keep the connection alive or not, and this defines the encoding standard that we are expecting to get back from the server. That request goes over to the other side, normally on port 80, and then we get a reply back again, and the reply actually has a header on it, and it also has the web page embedded into it. Remember that these might be TCP segments that are sent, so a large web page would be sent in several data packets which would be reassembled back at the other side. The server itself sends back a response, and the responses are, if it's 200, then it's a successful response, so 200 is okay. 300 means redirected, A 400 message is a client error, such as 403 is forbidden, 404 is that the page cannot be found, and the 500 error is a server error, such as 501, which is a bad gateway. Okay, so those are the main responses that we get back. And again, when we're sending back, we actually tell the browser the basic length of the content, so it knows to reassemble them, and the type of the content that's coming back, so that it can encode it in a certain way. Okay, so this shows a basic message that's sent. Get HTTP 1.1 is the most standard version of HTTP, and here we see all the different options that we don't actually see in the browser, but this actually sends extra options. You can see it's sending the browser details, what the host name is, and so on. In this case, the server responds back. So here is the web page in here. So you can see it's in the same message that comes back, and it's saying that that request is okay. It's telling us that it's an HTML document that's coming back, and its location, and when it was last modified, and so on. Okay, so the key thing here is that the header comes back from the server, and really the browser will pick off the header, look at it, examine it, and then use the HTML part if required. So let's actually have a look at a request. So we'll just use our analyzer here. And what we'll do is we'll just make a call to a site. Okay, so this is done a get from YouTube. You can see here is the header, and it comes back, and then I've parsed off the content, so you can see there is the web page that comes back from the request. We can ask for just a head. Oops. Okay, so you can see now when we've asked for it, only the header information comes back from it. If we want, we can use the options. It really just depends if the server allows that or not. Okay, so that shows a sample in real time. Let's have a look at our forensics traces, and we'll have a look at a very simple example. And we'll just load the WinPCAP file for our web page. Okay, so there's our three-way handshake. We communicate with the server with a SYN, SYNAC, and then ACK, and then we ask for the /, which is the top level directory, so it's going to return back the default web page, home page. And you can see there's the details that we're sending. You can see that's looking for a GB encoding. It's wanting to keep alive, and so on. So it's a very simple request. And then what comes back from the server, you can see is HTTP 1.1 200 OK. So you can see there that it's been OK, and it will send back the page. And it's obviously done that in chunks. Okay, so there's the whole page that's coming back. And one thing we can see is that there's a file called 2.css in there. So now the browser's got to ask for that CSS file. That's the style sheet. So the browser responds back with get that file, and then this is it returning it back here. You can see in between that we have AX, and this is us acknowledging that we've received the data successfully. We send that back to the server. So probably the easiest way for us to be able to see what's happening is to look at the follow TCP stream. So there's us, get, and there's the server response back, and there we go, it's responded back with the whole of the page here. And as we've seen earlier, there's a file called 2.css. So the browser then asks for that. We tell the server what we will accept, and again the server says that's fine, and it sends back the header information and the CSS file. After which we've now asked for an icon for the page, and you can see here the browser's responding back with a 404 to say it's not viewable. Okay, so the browser will then take all those files together and then render each one. Okay, so that shows an example. So now let's have a look at our own server, and we're running our Ubuntu image here. So let's just see if we are running. Okay, so we're running a server with inside Ubuntu, and this is it's out into Windows. So we'll have a look to see what our IP address is. And let's see if we can contact it. And you can see it's alive. So now what we'll do is we'll telnet. Telnet is a good tool to be able to actually debug network connections. And we'll connect on port 80. So this, we're now connecting into our web server, and then we should be able to enter our commands. So I'll type in get, G-E-T, space slash. You can see here, that's the page here that responds back. I could try head, and you can see here it doesn't like me doing that. Okay, so telnet on a certain port is a useful method to be able to debug our protocols. Okay, so that's showing an example of HTTP. So let's have a look at another application protocol, and that's the file transfer protocol. And it's used to be able to transfer files from one machine to another. The port that it normally uses is port 21. So we connect to port 21, and then we can send certain commands over to the server, and then it will reply back with responses, as we've seen with HTTP. So for example, the get command is used to get a file from the server, and the put command is used to put a file onto the server. The codes that come back, as we've seen, 200 codes are the successful operation. 200 is command OK. 300 codes it means that the command's been accepted, but it needs another receipt. 400 codes we've seen is that the command was not accepted, such as 421, which is service not available, and then the 500 codes is that the command was not accepted and the server is going to reset in some sort of way. So let's look at an example. So the first time we connect to the service, in this case it's a Microsoft service, we get back a 220 message, and it actually tells us, in this case it's an FTP file service. We then send through the username. In this case, username is administrator. Responds back with 331 to asking for the password. We then send the password through. In this case, the user's name, the password is Napier. Again, it goes through, and then if it's a login, we'll get a 230 error. Syst will then actually show the message that shows the operating system. PWD is the present working directory, and then we can actually have a look to see where we are. And then we go into a mode which is called passive mode. And passive mode is used most often inside FTP systems. And what passive mode does is it will create a port on the server in which the client will connect to. And the place that we actually identify the port which is opened up is defined in the return string. And it's these 2 digits here. What we see here is actually the IP address, and then the next part defines the port on the server which is going to be opened up, and we calculate it as 4 times 1024 plus 22. So then what we should see is a connection into that that port from our client. Okay, so the next thing we do is ask for a list of the files there. We'll change the current directory. Okay, so we can't see the files here, but what will be returned back will be a listing of the files. Again, we ask for a passive mode, and here is the new port which is opened up. We ask for ASCII transfer, and then we should, in this case we're storing a file onto the server. Okay, so this shows an example. So this is as we do change the working directory to the top level, then we get a response back. We now say we want passive mode, so what comes back will be the port that we connect to. So in this case 4 times 1024 plus 23 is 1047. We then had to do list, so we want to list the folders. So then we create a new connection onto the server on port 1047. We do the syn, synac and so on, and then the files are transferred on that port. In the end we get a 226 file transfer complete, and then the connection is broken. So we can see here that port 21 is only used for the commands. The actual file transfer happens through other ports on the server in a proactive way. Okay, so let's have a look at an example of FTP. Look at the Wireshark. So here we are. So there's syn, synac and dac. This is port 21 that we're using. As we can see here, port 21. This is the port we've selected. Okay, so there's the response coming back. The user then sends the username there's the response coming back, there's the password, and so on. So you can see here, this is us entering passive, and there's the port coming back. So we can see here it's port that we identified before. Then we do a list, and here we go. So here is the connection back. So 4 times 1024 plus 22 equals 1046. So you can see here now, if we follow that stream, this is the connection into the port. Just clear that. So overall we can actually have a look to see the whole stream. Okay, so there's us connecting, feeding the username, password, and so on, just as we saw before. And now what we're doing is we're storing the files. In this case we got a 550 to show that the access is actually denied for the file that we're storing. So all the files here that we've tried to store haven't actually been successful. Okay, so you can see all along we're opening up this passive port, and then we're requesting a list. There's the command there that goes through. And we can actually see the whole conversation. Okay, so in the end we just close the connection. So let's have a look at our VM. And on our VM, hopefully, and we need to find out what the IP address is. So let's just see if it's alive. And it is. So what we'll do is we'll connect to it just to see if the FTP server is alive. And we'll connect on port 21. Okay, so hopefully I can put in user. Oops. Unfortunately, that's not the right password. And there we are. Okay, so that shows our little client there. Now let's connect to it with an FTP server, with an FTP client. It's 192.168.47.132. Okay, so you can see up the top here there is our actual commands going through. Unfortunately, we weren't able to log in there. Hopefully this should work. Okay. Then we'll just send over a file. And we should be able to see the connections. Okay, so there's the store. There's us going into passive mode. This is the port that's opened up on the server. We then store. Again, we go into passive mode, open up a new port, list it again so that we can actually get a list here. And we can do the same. We can just transfer a file back. Okay, so there's the retrieve. Again, we open up a new port, we connect to it, and then we get the file back again. Okay, so this is showing an example of how we can use FTP. So let's have a look at a very simple protocol, and that's DNS, or Domain Name Service. And Domain Name Service will resolve domain names into IP addresses. Okay, so what we have with DNS is that we normally have a local DNS which we contact and ask for a remote address, such as intel.com in this case. If it actually has that domain name registered, then it will return back the IP address for us. If it doesn't, then it does a recursive lookup and it will go and contact another DNS server, and then if it doesn't have it, then it will go to contact another high level one. Then eventually it will respond back to the organization who's responsible for maintaining the records for that domain. Once they're updated, then all the DNS servers will be updated, and then we'll respond back to the client about the IP address. If the client asks for the same domain name again, then the local DNS hopefully has it in there, and then we'll respond back with IP address. The caching is obviously important, and the refresh time, because it could be that we change the IP address of a remote server, and it can take some time for the servers to be updated. So the record that we have must be updated by the domain owner. Okay, so this shows an example of a query. So we have some flags. In this case, it's a query, and then what comes back is a reply. So we have an opcode related to DNS for the query, and then we can do a recursive lookup or a non-recursive lookup. With this, a recursive lookup will keep asking higher and higher level DNS servers, where a non-recursive, if the local DNS doesn't know it, then it will reply back to say that it doesn't know it. So in this case, we're querying the record for the domain name. So we want its IP address, and the response that comes back responds back with the IP address. So we've already looked at NS lookup and so on, would be an example of this type of command. But whenever we use a web browser, we should see that it will get resolved to an IP address. So really, whenever we're communicating any time with domain names, then each time, unless they're cached, we will get that resolved to an IP address. So let's find our DNS. Here we go. So DNS this time will actually find uses UDP traffic. It's a very simple one here. So here is our query. And we're asking for the reply Okay, so this is us asking for intel.com. We're asking for the host address, and which is the A record. And there's the reply coming back. So it might return back more than one IP address. You can see here it's returning back 2 IP addresses there that we can actually use. And just to make sure, it's done it again. So you can see here that the port that's used is port 53, and it's UDP, very simple, UDP. And the source port that we're using is 63227 in this case. Obviously the next time we can use a different port. Okay, so as we've seen, we can use NSLOOKUP. To be able to resolve our IP addresses, and this should contact our DNS server. In this case I'm using a wireless router, so it's going to here, and it's obviously contacting a DNS server and getting this as a reply. In our Linux image, we can also use NSLOOKUP. Okay, so we've given an overview of 3 key application layer protocols.